guys. So we are going to talk about transformations to exponential functions given to us in the format of y equals a times the base raised to x minus h plus k. Not a lot changes as far as what the letters mean. So we still have an a out front of the function, which by the way, the function is b to the x. That's going to be our parent function. So we still have vertical stretches and shrinks. We have a stretch if the a is greater than 1. We have a shrink if it's a fraction less than 1. If it's negative, we still have the reflection over the x-axis. Next up, we have the h, which is attached to the x. Now, you won't see any parentheses with this one. Just know that it's h's are always attached to the x, so you have that side of it. And so if the h is positive, you're going to be moving left. If the h is negative, you're going to be moving to the right. Then brings us to the k, which is something that gets added after the function. So after the b of x comes your k. That's going to be the shift up or the shift down. Please remember k is the one you go in the same direction. So if it's a plus k, you're going up. If it's a minus k, you are going down. In exponential functions, we have something called the base, which is basically our multiplier. We kind of talked about it real briefly in class. This is going to be something doubles or triples, or when we're talking about the interest, I'm going to have an interest rate of 6.25%. You're going to be able to convert those into your multiplier, into your base, so you know how much money to add or take away or whatever it is you're working with. If you're working with animal population, you know how the animal population is growing or declining. So those are our bases. I don't care what the bases are, the transformations still stay the same, and the parent function is still the same. Whether it's a 2 or a 10 or a 20 or whatever, it affects the number slightly, but the overall look is exactly the same. Okay, so with that being said, I do want to talk about what the difference is between having an integer base and a fractional base, because that's going to make a difference in our graph, and you have some of those problems in your homework. So first of all, I'm going to graph the parent function so you guys can see how the transformations take place. Now, in the instructions for your classwork, no calculators. I want us to get to a place where we can quickly reference these things. And you're pulling these quick references because you're spending time learning the parent function's DNA. Where does it cross the x-axis? Does it cross the y-axis? Where are its boundaries? What is its domain? What is its range? What is it supposed to look like? Well, with saying that, I have the parent function that is supposed to look like it goes through the y-intercept at 0, 1. I know that it's going to hug the x-axis, and then it's going to shoot up. This is my parent function. Now, the reason I want to have this graph is so I can use a known point on the graph to do all of my transformations. Sorry, I'm trying to get a better angle. So the known point we're going to use is this 0, 1. That is the known point, especially since the instructions say, please don't use a t-chart. So now it's about taking those transformations and using our brains to say, oh, it's going to move every single point, up 1, right, whatever. It's going to move every point. Well, I don't want to move every point, so why don't I find one point and move the whole graph from there? This is what I'm going to talk about. So if I look at the first problem on my classwork, it's 2 raised to the x plus 3, then minus 1. What I know I have is I have a horizontal shift. It's a plus 3, so that means left 3. Then I have a minus 1, so that's a vertical shift. And that's going down 1. So what's happening is I'm going to take this y-intercept and I'm going to move him. I'm going to literally pick it up and I'm going to move him. And so I'm going to go left 3, so 1, 2, 3, and then down 1. And what I'm going to do is I'm going to then mimic the graph. So this graph is going to come down, up, and away it goes. And that is all I want from you at this moment in time. I don't need it to be technical. I don't need it to be super precise. I just need to see that you understand how transformations work at this point, and that you know what the graph is supposed to look like. You're supposed to know it's supposed to hug here and rock it up there. And that's the whole key part that you're going to be taking away from this. So again, I pulled my transformations from the h and from the k. I went to what I knew about the parent functions, that it crossed the y-axis, so it was a known point. I took that point, I shifted it over 3, and then down 1, okay? Now, what does a fractional base do? A fractional base is what I was talking about in class with exponential decay. I am no longer making money, I am now losing money. So instead of something doubling, it's now halving, or cutting it into 1/3 or 1/4. So the idea is that something went from being super expensive to losing a value. So the graph, instead of starting low and traveling high, meaning it was appreciating, I'm now going to start high, meaning I purchased it for a higher price, and it is declining in my cost. So I now am losing money. So when I buy a car at $30,000 and 10 years later, I sell it for, $10,000. My graph would start high and end low as the truck value or depreciated. So that's what this fractional exponent is going to do. It's going to cause the graph to start high and end low, but it holds all of the same values, okay? So I have here a horizontal shift of left 2, and then a vertical shift up 3, following my H's and my K's. Now, again, this graph would have come down and it still would have gone through the point 0, 1. So I'm still going to use the 0, 1, and I'm going to move left 2, and now I'm going to go up 3. 1, 2, 3. Only this time, I'm going to start high and end low. And that's what the fractional ones should do. The fractional ones should look like they're turned around. And that's what you're going to be looking at when it comes to your classwork tonight. Now that's for the exponential functions. I would like us to pause on the log ones because I want to talk about the different bases when it comes to logarithmic functions. So we'll go ahead and cover those in class since this is still a classwork assignment. So I do want you to cover all of the exponentials. I just did 2 of them. If you have questions, let me know. Post them to the video or hit me up on Remind, okay? Otherwise, I'll see you in class. Thanks, guys.